Bienvenidos al segundo workshop del proyecto Encore. Nos encontramos en la mesa de inauguración. Bienvenidos a todos los participantes, a todos los ponentes. Nos encontramos en la mesa de inauguración de este workshop al director de la Escuela Politécnica Superior de Ingeniería, don Felipe Monzón Peñate, y a la vicerrectora de internacionalización, doña Lidia Cabrera. Si tienen algún problema y no me escuchan bien, les ruego que por el chat nos lo comenten para poder estar atentos a algún problema de sonido. Recuerden que tenemos traducción simultánea, que en la parte inferior del Zoom pueden elegir el idioma en el que desean escuchar el workshop para, sobre todo, pues, poder seguirlo de forma pues, más fluida. Si hubiera algún problema con el idioma, también nos lo comentan en el chat. Tenemos a 2 personas por ahí de UAI Comunicación que nos ayudan en ese aspecto. Hacer una pequeña introducción del proyecto Encore y disculpen mi voz, cómo la tengo hoy, porque no es mi estado natural. El proyecto Encore pues, trata de abordar la renovación energética desde un punto de vista del ciclo de vida del parque inmobiliario de viviendas en Europa, y comentar solo 2 cosas porque el coordinador del proyecto va a dar una visión más global de todos los módulos del proyecto. Simplemente que este proyecto está alineado con los Objetivos de Desarrollo Sostenible, con el famoso Pacto Verde de la Unión Europea y con ese esfuerzo de digitalización que realiza la Unión Europea en el ámbito de, sobre todo, la pequeña y mediana empresa del sector de la construcción. En ese sentido, y alineado con nuestros fondos españoles de Next Generation, yo creo que el proyecto europeo Encore pues, está perfectamente situado en ese aspecto. Yo creo que con nuestro producto final de este proyecto, se podrían abordar muchos de los procesos de renovación en el ámbito residencial de forma más sencilla y con herramientas en la nube. Bueno, paso la palabra al director de la Escuela Politécnica, don Felipe Monzón Peñate.
Bueno, antes que nada, darle la bienvenida a esta su casa. La Escuela Politécnica tiene los estudios de náutica, de las especialidades de puentes, máquinas, electrónica naval, ingeniería agrícola, ingeniería civil y arquitectura técnica. Y por lo tanto, gracias a Lorena por invitarme y por desarrollar el proyecto conjuntamente con nosotros y decirle que está a su casa. El programa que tienen ustedes es muy intenso en el día de hoy y además la iniciativa del proyecto Encore está muy bien encaminada y veo que también tenían la parte de mantenimiento y quiero comentar que también es importante en un proyecto, tanto el proyecto, la redacción, la ejecución y también muy importante el mantenimiento, que a veces nos olvidamos las instituciones públicas que las cosas, aparte de serlas, hay que mantener. Sin más, le doy la palabra a la vicerrectora y bienvenidos a esta jornada.
Bien, muchísimas gracias. Buenos días a todos y todas. Bueno, señor director de la escuela, directora del proyecto Lorena, profesorado todo en línea, profesorado presente. Bueno, para mí es un placer estar aquí en nombre de la Universidad de La Laguna y sobre todo en nombre del área internacional, pues dando la bienvenida a este workshop y sobre todo para este proyecto de tanto impacto. Bien, disculpen, no sé si se me oye bien, no me quiero quitar la mascarilla, soy población un poco sensible y todavía tenemos que estar con los cuidados, las medidas preventivas para el COVID. Bien, decirles que bien, para mí estar en actos de estas características donde se fomenta el tema de la internacionalización, pues bueno, pues es un enorme placer. Y en el ámbito de la ciencia, pues me congratula sobre todo la investigación que últimamente se está haciendo en red, con consorcio, porque no es lo mismo hacer investigación para el mundo que con el mundo, como yo siempre digo. Hacer investigación de forma conjunta es fundamental en el mundo en el que vivimos, en esta sociedad tan global en la que la interculturalidad, por un lado, por otro lado, los problemas que nos afectan son ya problemas que no son comunes, y por esa razón ya no se puede hacer ciencia aislada, pues porque los parámetros contextuales son importantes a la hora no solo de plantear los problemas, sino de tratarlos, y la ciencia tiene que ser justa en ese sentido y contextualizarse. Bien, por otro lado, los retos de las universidades, los retos de la ciencia, pues es construir ciencia a escala indisciplinar y con todas esas perspectivas diferenciales, culturales, y ustedes lo están haciendo en este grupo. Por esa razón, lo primero que tengo es que felicitar a todo el consorcio por haberse constituido, y sobre todo por haberse constituido también en un proyecto, en un ámbito que parece que de mucho impacto, muy estratégico, el modelo BIM, que están siendo una revolución digital en la industria de la construcción. Y también tengo que felicitarles, Lorena, a todo el grupo, pues el que hayan tenido la consideración de proyecto relevante por la Unión Europea y que haya sido financiado bajo esta estrategia, la más competitiva en Europa, de Horizon 2020. Bien, pues yo solo espero que los resultados del proyecto tengan mucho impacto a nivel mundial, y que ese impacto no sea solo para fortalecer al grupo y fortalecer a los investigadores del grupo, sino también para la mejora del planeta y su sostenibilidad, como ustedes plantean en los objetivos. Bien, la UL tiene desde hace más de 20 años un campus intercontinental que se llama Campus Atlántico Tricontinental, es un campus de excelencia. Con esa acción nosotros lo que pretendemos es que la región canaria, en medio de 3 continentes, sea referencia para la investigación europea para proyectos estratégicos con África y Latinoamérica. Por esa razón a mí me congratula mucho que hoy se esté celebrando aquí este workshop en una zona geográficamente en África para el desarrollo de investigación europea, y espero que sea también una referencia, que ese conocimiento no sea solo conocimiento para el norte, sino que sea también para el sur, Lorena. Bien, nuestra universidad a nivel internacional, como todos conocen, en ciencia tiene un posicionamiento bastante considerable. Eso es posible gracias al trabajo diario de grupos como estos, por los que también les agradezco mucho y les felicito. Y bueno, no más, solo desearles que la jornada de hoy sea productiva, que sea enriquecedora a nivel académico, y que también sea una oportunidad para seguir reforzando esa red, ese grupo, en colaboración y cooperación. Con mucho placer, le doy la bienvenida a cada uno de todos ustedes y doy por inaugurado este workshop. Y sin antes no felicitar a la organizadora, creo que es un grupo organizador, pero sobre todo a la coordinadora de la organización, Lorena. Y por supuestísimo, pues muchísimas gracias por invitarme, y muchas gracias a todos por la atención.
Gracias a la universidad.
Good morning, everybody. Welcome to the workshop, to Encore's workshop. I would like to officially welcome you on the behalf of the project consortium to this workshop that is taking place in Tenerife. I would like to introduce our first panelist, Mr. Sebastian Scholze, the Encore coordinator. He is a senior scientist in the Institute for Applied System Technology in Bremen. Sebastian, the floor is yours.
Just the first, I will start with sharing the presentation. So I think you should see it now in full screen. So welcome everybody. Also from my side, my name is Sebastian Scholze from ATB. I'm the coordinator of the Encore project, and I'm very happy that we are able to present our project and especially the results during our today's workshop. It's a pity that we can't be all there in Tenerife, but when I look out of the window, at least we have some sun, so we have some feeling that we could be there with you. Okay, in my presentation, I will give you a short overview of the Encore project, and then about the web-based portal. That's the entry point and starting point for Encore renovation projects. And then in the 7 further presentations, you will see more detail on the other technologies that we built during the project. And then last but not least, you will also see what we did in the our pilot case. So Encore, Norena already said that aligned with the Green Deal and this industrial sustainability call. It's a Horizon 2020 project, started in January 2019, and duration is 42 months. That means we will finish the project by end of June in this year. So we are nearly done. And you will see that we have quite good results. And on this map, you can see where our partners in the projects are located. So we have a nice distribution all over Europe. And I think that's quite good from European point of view, but also from point of view of renovation projects, because we have definitely different climate conditions in the project. Our main objectives, I will just read this: to provide effective and affordable BIM tools that accelerate the whole renovation lifecycle. So everything from collecting data to project execution, and then also commissioning and delivery, and taking into consideration energy efficiency and comfort parameters, and involving all the actors in the process. So that was our main objective. What does this mean in more detail? So if you want to renovate a project, you need a model. And when I look at my house, for example, there's no digital model available. It's still an old hand written model. So what can we do to digitalize this? We have several ideas had several ideas in the project. And one is, for example, that we can acquire the data by using drones, so that you can fly around a building and then using LiDAR and photogrammetry to build this model. In order to do this, we need some automatic segmentation and classification. So to identify, for example, what is a tree, what is a building. And by this, we want to fully automatically generate building models. And when we have this model, that's of course not perfect. So we need also some tools to enhance this automatically generated model. When we have the model ready, we also want to do simulation. So what can we change in the building so that we can have better energy efficiency? For this, we need energy efficiency and comfort simulations. And then if you want to go to the next step, so the renovation itself, we need some feedback from the end users. And the idea is to use this with augmented and mixed reality. And to support the construction crews, we automatically generate tasks, what the crews have to do. And then last but not least, we also want to provide continuous monitoring of the facilities. If we look at our architecture, it looks like this. We have a layered architecture consisting of these 4 layers. So at the bottom, we have the data sources, for example, different BIM objects, then photogrammetry and LiDAR. So the point clouds, for example, what the drones are generating when flying around the building. Then we have different sensors, but also data from weather stations and GIS information. When we have this information, we need to do some data capturing in order to have this data inside our Encore engines, and that's the orange or yellow layer. So on the one side, we automatically want to create models, so BIM models. And on the other side, we also want to create knowledge. And then this we want to combine. So for example, using data from sensors and to combine this or feed this into the model. And then on top, we have several applications. And this you will see during the next presentations. So that's our architecture for the Encore project. But now the big question is what to do this. So we decided to create a, let's say, standard Encore workflow. And this looks like this. What steps you have to do an energy efficient renovation of a building. So of course you start with a project generation, then you can either generate or add building models, assess energy and comfort before the renovation, define some renovation alternatives, and so on. You can step by step go through this workflow and then see how this is supported by the Encore tools. Now that we have these standard Encore workflow, you already see these gray lines. We have combined this with, on the one side, on the right side, with external data sources, but then with our software tools that are supporting this workflow. And here you can see, once again, the blue ones is the web apps that we built to support this workflow. Then we have in yellow these backend services that doing the real work, and then of course some interfaces to external systems. So this may be in very short about Encore in general. Last slide about Encore in general. As I already said, we started in 2019, summer 2019, we had the concept and the architecture ready. Then around 1 year later, we had some first prototypes on the software, tried this out, and then another year later in autumn 2021, we had the full prototypes ready. And since this year, we are validating and assessing our tools and optimizing them. And then summer 2022, we have the final prototypes and the demonstration, and then we also finished the project. So that's the first part of my presentation. That's about the Encore project. Now I would like to show you the entry point if you want to use Encore. So this is our landing page. So it's the central point for an Encore user to access the Encore solution. So you can sign in, and then you will see a project overview. Here, just an example with 2 projects. And then from there, you can access the project which you're owning. Let's do this green one, IDEA demonstrator building. Then you will see an overview page, and the first step is this project basic info, where you can enter and see then some basic information. So the name, what is the customer, address, country, number of inhabitants, what is the type of the building, and then some free text as a description. On the right side, you can see all the people that are involved. For this example, it's just the project coordinator, but you can add here users that have to work with the project or that are can see the information. On the left side, you can see all the tools that you can access. For example, the building monitoring, the energy and comfort simulation, design analysis, work planning, building operation support. So these are then the web apps that you can access directly from the web portal. And the interesting part, if you look at this part with the 3D building models, So imagine either you have already a 3D model or you have generated one using the drones and the image processing service. You can add this model here, and then we have an integrated BIM viewer, and you can see the building or what is in the model. This is from our test case in Caceres. That's the demonstration building, what they have. And this is the situation as is. So now you have defined what you want to renovate. So you have an updated version of the building model. You can again see this in the BIM viewer. And you can see I selected here on the top two elements that we want to add. So the idea is here to add some shades to the windows, so to reduce heat. And that was what we want to do in the renovation. Now, in the background, we have also added some sensors to the building. And in the background, now the knowledge enhancement service automatically connects these sensors with the elements in the IFC. So you have an enhanced IFC building model. And here again, you can see then on top that you have this building element and it's connected to a specific sensor and some data units. So by this, you can automatically enhance a building model. And this can then be used by other components. So that's the entry point, and that is my part of the presentation. And then I would suggest that we continue with the other presentations to show you the other modules in much more detail. So if you have any questions, please feel free, or we can also do this in the end. Thank you very much.
Thank you very much, Sebastian. If there are no questions, I would like to introduce to everybody Mr. Sergio Munoz, which is the CEO of Florentia Technologies, a startup located in Valencia. Sergio is going to present the online data acquisition module of Encore. Sergio, the floor is yours.
Thank you, Nikos. Can you confirm that you see my screen?
Yes, yes, we can see it.
Okay.
Thanks, Nikos. Can you see my screen? Okay, well, in my case, I'm going to take advantage of the fact that the workshop is physically held in Tenerife to make the presentation in Spanish. As Sebastian has introduced in the core project, a series of services and solutions have been developed to help the entire energy renovation process of a building. Which is good. Well, one of the starting points is the definition of the current or existing state of the building that you want to renovate and generate information in this case. Well, the methodology is the backbone of everything that this process is well generating a model of information from that existing building. We are going to see different procedures, different technologies, or different solutions to generate it. In my case, I'm going to focus on one. It is the use of existing information in different online sources, offering geometric information of the existing building stock, and what we can use them as a reference to reconstruct or generate the model of building information with at least the most relevant parts to be able to do an energy analysis, what the envelope would be, what the spaces would be. In our case, the sources that we have collected and incorporated into our service are free. We're going to talk about cadastre, specifically that cadastre that exists in Spain. after another source of information called 3D building, and finally we will use, let's say as a base, a plan offered by Google Maps to be able to draw the outline by hand in a relatively simple way, to be able to generate the volume and process for all cases in a bit similar to the one shown here, with information about the number of levels by number of floors, the height of each floor, and what percentage of opening we have in the facade. In order to be able to destroy and generate the building, by explaining a little bit what we can do with each of the sources. In the case of the cadastre, well, yes, we are investigating or exploring the different national cadastres in different countries in Europe. But the truth is that each one has the information in a different format. Some offer information for free, others it's paid information. And we found that it's not possible to use a single method. So let's say of consultation for all. That's why in this case only this system is good for us, especially for Spain. But the good thing about the cadastre of Spain is the fact that it offers fairly and up-to-date information. It also gives us information on the polygon of the contour that there is at each floor, with a good level of precision. It also tells us the height of the building, in addition to whether there are levels below, and other additional information that could be interesting, including the year of construction. We also have developed a method to be able to distinguish if an exterior enclosure is a facade or a dividing wall. What is certain is that you can consult the cadastre online. We can bring you, let's say in real time, the cadastral files of each municipality in the 6 countries. We were able to download ourselves on our server to work with them locally. Okay, here we show a list of cadastral files that we have in our server. The second of the options that I told you about, 3D building, is a global database of buildings with many millions of buildings. But it is true that there are different levels of detail depending on the city and the country of a database, which is growing today. There are cities where all the buildings are very well defined, and there are cities where maybe there is only the outline but not the number of floors. There are also smaller cities that perhaps do not have or are not yet in the database, which is good because it has a limitation on one side, but on another side, it's true that it still allows us to use it for many cities in Europe. This is an example of 3D building that we have of Santa Cruz de Tenerife. And finally, as I told you, we give the developer of our tool the possibility that the designers then generate their own models of the buildings in a very simple way. And the main limitation is only when the geometry is very complex. Hence, this method might not be suitable in that case. But basically, using Google Maps as a reference, what it does is follow a series of polygon lines that define the contour of the building and then indicates the number of floors. It can generate an inner courtyard and select each of the external enclosure, for instance, if it's a facade or a dividing wall. As I told you, in any of these methods, what we do is reconstruct from the information of each one of those floors and finally generate the volumetry of the existing building, on which we want to do the analysis. For this, we have a result like this one. What you're seeing here, and I'm going to do it in a way, even though I had some videos to demonstrate it, I'm going to try and do it now. So let me do an online demonstration And so in this case, we have a building located on 25th La Salle Avenue in Tenerife. And the next step is the generation of geometry. So I start with the part with the cadastral route that I tell you, the one gives the most complete information. So in Spain, here we see, let's say from here, we already have some information, for instance on the fact that it has underground levels, and also the number of upper floors, and also the height of each level. So with this, then I will explain it later because we have to characterize the different construction solutions as well facilities. So with this we generate this model that, as you can see, is quite large. So of the building, going back so that we can see simply the differences of what happens if in this case we use 3D building. Okay, so we see that the contour is a little more simple than the other one that was there. We don't have the information if there is basements below the ground. But well, for buildings from outside Spain, well, yes, it's a solution that may be perfectly suitable. So we obtain these results from this day. And well, finally, the last options that I was commenting to you, the manual drawing. So sometimes it happens that the cadastre generates all that. But sometimes the building, there are several buildings and the cadastral information that joins several buildings, so it can be interesting to draw directly, which is a good part maybe, that interests you assuming only the outside part. Here, we're going to indicate that it has 6 floors, that it expects a basement, and by the way, although I know it does not have it, I'm going to add an inner courtyard, and I'm going to tell you how far this courtyard arrives. So it reaches the bottom completely. This is a simplification. Then it's true that we have collaborated from many energy simulations, that it's not necessary to have one excessive detail of the envelope to have an approximation of the energy behavior of the building and the impact that the rehabilitation solutions can have. Well, as you can see, we have been able to generate this building model in accordance with what we have indicated. So from my side, that's it. Later, I will tell you some more things we do at Encore. Thank you, Nikos.
Nada más. Luego os contaré alguna bueno, más cosas que hacemos dentro de Encore. Muchas gracias. Thank you, Nikos.
Very much, Sergio. We are continuing with the presentation from the University of Zagreb. The panelist is Professor Stepan Bogdan, and the presentation will be regarding the UAV data acquisition. Stepan, good morning. The floor is yours.
Thank you, Nikos. Just give me a second to share my screen with all of you.
Sure.
Hi, everybody. As Nikos said, my name is Stepan Bogdan, and I'm coming from the University of Zagreb in Croatia. And we are partner in the Encore project. In some way, what I will describe and talk about is data acquisition service, which is in line with what Sergio just described to you. And in our case, we are partner that provide data acquisition service by using unmanned aerial vehicles. So actually, before I start, I would like to say that all of the things that you will see today, this next 10 minutes, actually won't be possible if there is no bright young man who actually have done all this job. And here you see my PhD students and also postdoc Frano, who actually worked on the project. As Sebastian and Sergio already said, the main purpose of Encore is to provide a tool for architects to be able to renew buildings and to make those building cost effective. So a few presentations, you already seen this one. And also Sebastian showed the Encore architecture, which is again here on the slide, just for you to, for me to point out where our service, our data acquisition service done by unmanned aerial vehicles actually belong to. And this is the part at the level of data sources and data capture. Sebastian said that we provide actually point clouds, as you will see later on, and also photogrammetry that is later on taken by our colleagues, which do image processing and reconstruction of data that we provide. So how this works, actually what we have a two or three vehicles that work in parallel, that fly around the building, following particular trajectories that are provided by graphical user interface. And once we have point clouds and photographs of the building that we would like to reconstruct, then a 3D model is done, and elements of this 3D model is reconstructed, so all parts, windows, doors, etc. And finally, once we have those, we can provide a BIM model, which is the final goal of Encore platform. This is the workflow, so data acquisition, model creation, then we transform model, validate the model, and finally execute renovation of the building. So, same as Sergio presented workflow when you acquire data directly from Cadastre, I will show you here the workflow for data acquisition done by unmanned aerial vehicles. We are also using Google Maps and also Cadastre. And once a particular building that we would like to work with, that would like to go around and take a point cloud and images, once we pick this building, then in a Cadastre, operator sets the waypoints. Those waypoints are usually parts of the building or layout of the building that we would like to fly around with UAV. And those waypoints are important, as already mentioned, because we would like to know the trajectory for that vehicle should execute. So we have those waypoints, and then a trajectory builder that is part of data acquisition service and that runs on a human-machine interface provides trajectory for 1, 2, or 3 vehicles, depending how many UAVs we would like to use simultaneously to acquire data. I will show later on a live demonstration how we do this with the 2 vehicles, with 2 UAVs. Once we have trajectory, we just start the mission. Mission is executed. Here is the simulation of the UAVs flying in virtual reality. We all, before real flying, we test everything in virtual reality to be sure that everything works as it should. And then we go in the real world and provide data sets, images, and point cloud. So this is the workflow that is required for data acquisition service by unmanned vehicles. Parts of DAS, we have a ground station, we have UAVs, as I said, 1, 2, 3, and also we have a control station. Here are just the parts of those components. On the ground station, we are running human-machine interface, HMI, and also we have full communication with all 3 vehicles. Those vehicles, on-board vehicles, we have a computer that controls the trajectory execution, follows the wall, and also controls the attitude of the vehicle. Everything is done autonomously. So there is a pilot, there is operator of the UAVs, but this is just a safety pilot. So once we have a pre-planned trajectory, operator actually just press button and then vehicles take off and start execution of the trajectories. And the task for the operator is just to check if everything is going smoothly. So if there is no situation that requires his or her intervention, vehicles should go around the building and then land autonomously. Hardware of the UAV, so this is custom-made UAV. Some parts of the UAV are standard. What is not standard is, for example, this LiDAR that we put there, and some cameras and computers that are required in order to process huge amount of data that we acquire. Preparation and execution of the experiments. As I said, HMI, we have a link because we are using wireless communication. This is controller that is used by operator here. And finally, those two vehicles that you will see later on, how they fly around the building. Now, I will show you a video clip that actually demonstrates how work is done. What you can see here is a graphical user interface. So here in this part of the screen, you see Google Map. And this is Google Map of the building in Cáceres, where we have done our experiments. There are 3 vehicles. HMI is built for 3 vehicles. At the moment, we are using just 2. So this red one and the blue one. And position of red one and blue one are here close to the building. We are using GPS signal. On the right side of HMI, you can see data that operator could track, for example, latitude, longitude, flight altitude, distance from the building, and all other things that are important for operator to know what is the situation with the system. Okay, now once we have a Google Map, what operator does, as you can see, he puts points on the building that we would like to fly around, and once those points are set based on coordinates of the UAV and coordinates of those points on Google Map, we calculate, program calculates trajectory that should be executed, and then operator is able to see those trajectories. As I said, we are using 2 vehicles, red and blue one. Red flies 6 meters from the ground around the building, and blue one flies 12 meters around the building. And here you can see those points that are coming up, actually actual data coming from the vehicles. Here also operator could pick and choose to watch what is going on a Google Maps. This is trajectory that should be flown by vehicles, and operator in real time tracks blue and red vehicles that fly autonomously around the building. As I said, only in case of emergency, operator takes over the vehicle and use RC control to land the vehicle. Okay, then what is the final, how this looks like actually. This is the video clip of vehicles flying around the building, red and blue one. So they're in position. This one is on the 6 meters. One that is behind the building was on 12 meters. The final result, this point cloud that we acquired by using LiDARs, is shown here on this video clip. As you can see, those are raw data, so operator could check the quality of data, if something is missing, and so on, if flights should be repeat. And then later on, those data go to our colleagues, as I said, that reconstruct parts of the building from this data. What is very interesting, for example, if you open windows of the building that we are flying around, then we can obtain the point cloud from inside structures of the building, which you can see here. For example, here you can see doors, some walls inside the building. So this also could be captured by data acquisition service, even though the primary goal of data acquisition service is to acquire data from the outside environment of the building. Okay, so this was my 10 minutes. Thank you very much for your attention, and of course I'm here to answer any question if you have that is related to data acquisition service. Nikos.
Thank you, Stefan. Now it's time for our colleagues from ETH Zurich. Rui is going to present the 3D image reconstruction and processing. Rui, the floor is yours.
Hello, everyone. Welcome to the presentation for the image processing and reconstruction service for Encore project. And we are the team from ETH Zurich. And our team members include me, Ajat, Denda, and Luke. And the image processing and reconstruction service pipeline aims to automatically reconstruct the IFC model from the 2D RGB images and the 3D LiDAR points collected by the University of Zagreb, the data acquisition service. And now we show some of the demos that we can achieve now from the input 3D points and the 2D RGB images to get the final IFC model automatically. And our pipeline includes several modules, which can be summarized as following. We have the data acquisition service and data pre-process, and then 2D building element segmentation and 3D building element segmentation, and the final IFC generation. And we use some of this simple sentence to more summarize what each module does. In the first module, we would like to pre-process the data acquired by the DAS service. And then in the 2D building element segmentation, we would like to find the windows and the doors in the 2D images. And in the 3D building element segmentation, we would like to find the different elements like the windows, doors, and the walls in the 3D point clouds. And in the final IFC generation, we use the we use the detected elements in the previous modules to automatically generate the final IFC model. And in different modules, we develop some of the techniques to help the Hero IPR's pipeline. For example, in the 2D building element segmentation, we do the image semantic segmentation, the adaptation. And in the 3D, we have the image and geometry element and plan segmentation. And in the final IFC generation module, we developed the automatic IFC model generation toolbox. And following, and I will detail each module following. In the 2D building element and in the 2D building element segmentation module, we would like to find the windows and the doors elements in the 2D images. So for the idea can be summarized as following. After getting the 2D RGB images, we would like to know where the windows and the doors are. So the answer is that we would like to use the semantic segmentation to realize it. And the semantic segmentation aims to assign the semantic label to each pixel of the image. However, the typical semantic segmentation techniques rely on the large-scale labeled images, which takes much time and cost. And we can find some of the public facility set which has already labeled the different elements like the windows and doors in the images. So it can save much time and cost for us to label. However, the problem is that in the public facility sets, the labeled image is in the left side, but in our uncoded set, the images are shown in the right side. Obviously, they look very differently. So without using the adaptation technique, we directly train the semantic segmentation model on the public facility set and test it on the uncoded set image. We will find that the semantic segmentation result will be very bad. So we developed the adaptation techniques to use the unlabeled Encore dataset images and the labeled public facility dataset images in the training, and align the semantic segmentation map to improve the semantic segmentation results on the Encore dataset image. So finally, we can improve the Encore dataset to the image semantic segmentation performance. And here we can show some of the qualitative results. Without adaptation, it is shown that it cannot be segmented very meaningfully. And finally, with the adaptation, we can know that the windows and the doors can be segmented randomly. And next module is the 3D building element segmentation module. We would like to find the windows, doors, and walls in the 3D LiDAR points. So our strategy is that we have the 2D and to 3D mapping, and we have the 3D plan segmentation. In the 2D to 3D mapping, we reproject the 2D images to the 3D point cloud to find the windows and the doors in the 3D point cloud. And then with the 3D plan segmentation module, we can find the roof and the walls in the 3D points. And next, in the final FC generation module, we developed the first automatic point to IFC toolbox to automatically generate the IFC model from the segmented windows and the doors elements and the roof and the walls elements in the point clouds to get the final IFC model. And we try our pipeline on different places building. For example, this building is from the University of Zagreb, and then we can get the IFC model, and then we automatically from the acquired 2D images and the 3D LiDAR points. And also this building, this is another building from the University of Zagreb. We can also get similar results. And in the in our full prototype, we take the images and the LiDAR points collected by DSS from the spin, and then we get the final FC model. And this this building has multiple floors, so it proves that our pipeline is suitable for different scenarios, not only for the single floor building, but also for the multiple floors building. Okay, thanks a lot for your attention, and that's from our side, from ETH. Yeah.
Next up in the schedule, in the agenda, again is Sergio with the building energy modeling and energy savings and comfort simulation from Laurentia and also the University of La Laguna. Sergio, the floor is yours.
Thank you, Nikos.
We will divide the presentation into two parts. Well, we're going to talk about the fact that it is not enough to have the geometry of the building. Also the information in the model, only geometric information. So we need more things to be able to carry out the evaluation or energy analysis of the building at that time. We need to enrich the geometric model that we have already generated through points, as Sebastian was commenting before, or through the online sources that I was commenting before. In any case, it is the information model we need to enrich and give the information about the materials that make up the construction solution, and also what the installations are, what heating, ventilation, lighting, hot water, and services that are part of the building. Because, well, one thing that we have not mentioned and that we were going to comment on later is that the set of solutions that we have, we compute the calculations for the energy plus motor. Part of the process and simulation we do it through the calculation engine in the Energy Plus. And the Energy Plus calculation engine combines, on one hand, information on the building, and on the other hand, climatological information. And this climatological information is useful for a text filter. In a specific and EPW format, we have a database of many cities in Europe with that information, so that in each case we can have the closest climatological file. And on the other, the building information. Well, apart from the geometry, we need information on the protection or the physical and thermal properties of the constructive solutions and the behavior it enhances. The performance that the technical installation have also later to the simulations. We will need information loads that the building may have the occupancy of the operating hours of use, since all that operational information is necessary. Regarding what information we need here, we're very specific because for the determined use that we're going to make of energy evaluation of the building, we do need a large amount of information, or we do not need many properties of the constructive solutions. Then we need very specific solutions. We have focused on having, from the geometric point of view, the 3 dimensions in a simplified way, including openings, and identified the types of materials and the thermal properties that these materials have, thermal conductivity, specific heat, and also density, thickness, roughness, and from the point of view of installations, in this case, we did not incorporate their geometry, but only their location, type, efficiency, power, and performance. What we have done, well, from what I showed you before about the generation of that model of the building, we generate them, and automatically in the format that they need is a plus that it is, and here is an EDF, but in the event that we have generated the model by another means from the cloud of points or as an authorship modeling tool directly, and we can have them, and we need to transform this information from EDF to IFC. So it is good for this because some university has developed a tool that basically takes NFC models, extracts the fundamental information that they need to simulate and generates an IDF file with all that geometric information where, well, the building is, its location is the different spaces, the geometry of the spaces, of the construction elements along that is necessary to incorporate the information of the materials of the facilities. To incorporate the information, we have developed a database in the project that contains information of the existing elements. Also, trying to thinking about elements because they could be from 50, 80 or 100 years ago, that current manufacturers are not characterized, by which, well, we have a fairly complete repository of the constructive elements. In addition, we can extract a solution of a facade from the database and use it in our own project. If we want, we can export it to IFC for an authoring tool and integrate it. Well, here I show you some screenshots. So from our database in our repository, the same equipment where here we have heating, cooling, lighting, hot water, ventilation, and we have also incorporated home automation or automatic control system. It is also a possible renewal strategy, and you've seen it, but I think you've seen it in the demo before. In the tool, we do an assignment in a very first visual step for the entire building, in a global way that we can then personalize floor by floor, or even facades, which elements are part of it. Well, as I was saying, once we have enriched the model, we generate an IDF file with all that information, which is what we will see. We will send to Energy Plus to be able to launch the simulation. I'm going to make a small demo of uploading a file. An exercise in this case, we changed my origin of geometry for that of an IFP file.
Hacer una pequeña demo de subir un fichero IFC en este caso, o sea, cambio mi origen, ¿no? de la geometría por la de un fichero IFC.
Okay, in this case, it showed me before that my building was in Tenerife, but my IFC file is located in Madrid. I'm going to click yes. We're going to Madrid, a small building. Well, this is the assignment part of some default constructive solutions that later we can specify.
De unas soluciones constructivas por defecto que luego podemos especificar. Bueno, en Madrid voy a decir que sí que calefacción.
Here we have the geometry from IFC, and here, as I was saying, well, we can change my facade solutions for the entire building. If I want the same thing, well, with the windows, type of frame, type of glass or collage, equipment to give, and we would already have saved. Okay, with that said, I'm going to move on to the next part, consisting in carrying out the energy analysis of the building. Just wait one moment and let me make sure you see my full screen. Can you see my full screen? Yes. Okay, well then, the objective is to analyze the energy consumption. You are seeing PowerPoint format. I have it on the other screen. Okay, you see the PowerPoint format, but later you'll see it different. So let's try. Well, I don't know why it opens on my other screen, but I leave it in PowerPoint view. As I was telling you, to analyze energy consumptions, what it is we do good with all that information that we have. In our file from IDF, we launch it with the climatological file, but well, what we extract after the results is the energy consumption is different, because derived from hot water, sanitary, heating, cooling, and lighting. For that, to be able to compare it and see the impact that different rehabilitation strategies have on us, I'm going to leave with Jose Miguel, who is going to tell you about the work we have done to analyze different construction typologies in different climate zones of Europe. Jose Miguel, are you there? Here I am, yes. So, well, as Sergio said, we have carried out a series of simulations to establish different rehabilitation strategies in the buildings. For this, what I have done in the first step was to divide Europe into 3 regions with 3 broad climatic zones, in Southern, Central and Northern Europe, as obviously colder zones, from very cold to very, very cold. And on the other hand, we have established 6 types of housing that we understand can be common to almost all European cities. These types of houses can be buildings shaped as rectangles, buildings shaped as towers, L-shaped, C-shaped, also with inner courtyard or social housing. The types of strategies that we have worked with, we're going to talk about now. We have to do with the envelope fundamentally with the levels of insulations, with the modification of the carpentry and the glass of the windows, but also incorporations of shade elements to protect us from solar radiation during summer. On the other hand, obviously, because there are also other types of strategies that we have to do with the facilities, such as actions on the heating system, the cooling systems the buildings have. Next slide, please. Great. In the first place, we have worked with different levels of isolation, always proposing the isolation for the exterior of the buildings. And as you can see here for the cities of Southern Europe, well, First, something important I didn't mention before. For each of these climatic regions, we have selected 3 cities: Madrid for Southern, Berlin for Central Europe, and Helsinki for Northern Europe. In the case of the simulations carried out in Southern Europe, in Madrid, we can see how through insulation we can achieve improvements in the building's energy consumption of up to 64%. But note that in the first 4 to 8 centimeters of isolation is where the greatest impact of these improvements occurs. Next slide. Instead, in both Central and Northern Europe, we can achieve improvements that are around 50%, and once again, as you can see in the graphs represented here, the greatest impact of these improvements always occurs between the first 4 to 8 centimeters, where at 8 centimeters, as you can see, in heating we obtain improvements that are close to 45%. Next slide, please. The next step has been to evaluate the influence that the modification of the carpentry windows has on both the carpentry and the glass. Working with carpentry of PVC and with double glazing of buildings, note that in Southern Europe the influence of glass can reach up to 30% improvement, depending on the type of level of insulation with which we are working. Next slide, please. Whereas in Central Europe, we can achieve improvements that are around 20% simply by modifying the carpentry and glass. As we have said, if now we combine both following solutions from Sergio, and we see the influence that both the insulations and the modification of the carpentry and glass have, since we can see that in Southern Europe we can obtain improvements that reach up to 70% improvement in heating using double glazing, PVC carpentry, and 16 cm insulation. And if we go to the next one, we can see, as in Central Europe and in Northern Europe, in Berlin and Helsinki, these improvements are a little bit smaller, but they are still relevant enough, since we can achieve improvements that are around 60% in heating demand. It is important to point out that the importance from heating action occurs both in the continental cities of Southern Europe, as well as in Center and in North. But where refrigeration really has the greatest impact is in southern cities, which is what we will see in the next slide, that with solar protection reducing or minimizing the impact of the solar radiation has on buildings, we can obtain improvements of 20%, of 15 to 20% in what is the field of refrigeration. And now Sergio will show you a simulation carried out in a building in Tenerife. Perfect, thank you very much, Jose Miguel. So I have a video here, I think it's this one. I'll show you in a video because the simulation takes 2 minutes and I think it wasn't the case to keep you waiting. Okay, here it is. Well, in this case, I didn't include the option of heating equipment because, correct me if I'm wrong, Jose Miguel, it's not actually necessary for Santa Cruz. And the truth is that most of the consumption is taken from the domestic hot water. A little bit of the part of cooling and just very little for the lighting part. One of the things that I think are very interesting is that we have done this relatively quickly, so we can create different alternatives to study a little what we want. So the time analysis generation of proposal is fast and possible. So let's try to play a little, say, well, let's change the type of windows for this other type, change the type of lighting for another, and then generate many studies as you want, and later compare them. So here, let's compare. So in this case, well, I think I've changed the equipment, and I think the windows, the lighting, so for a slightly more efficient one, and we see some small saving, but in this case it doesn't seem very significant strategy. So from an economic point of view, it would take 300 years to amortize the investment. Well, they are also the ones that are good because it allows you to realize where or which ones have an impact and which impact is greater. So at least from the economic and energy point of view, it is worth it.
Y este tipo de cosas pues son también las que, bueno, pues te permite darte cuenta de dónde o cuáles tienen un impacto, ¿vale? Un impacto mayor, por lo menos desde el punto de vista relación económico y
Because there are measurements by José Miguel sequences where the impact depends on the climate region, and we recommend taking that into account. Well, we also have a series of recommendations, but since it is then the project technician who generates different options, analyzes them, and after that decides which is the most convenient one, we just focus on the simulation results. There is another part of the project where you can even do a constructability analysis with other technologies. So this is it for my part. I don't know if José Miguel wants to add something, and if not, we are done, and we are available to answer any type of question.
pues aquí estamos a disposición para resolver cualquier tipo de duda.
So a very brief comment that along the lines of these files, we have just seen that we are developing a series and effectively a series with each one of these buildings, and for each one of the climate zones we are establishing a series of files that we hope that will be published on the Encore portal as a reference to be able to establish different renovation strategies depending on the characteristics of the buildings and the climate zone in which one is located. Great. And also I understand that this is something that can be useful even for public administrations with regard to their own helplines or promotion of rehabilitation strategies, and to promote precisely those that have a greater impact. Yes.
Pues por nuestra parte nada más. Nikos.
Thank you very much, Rui.
Yeah.
I believe it is time for a 15 minutes coffee break, and we will be back shortly after to continue with the rest of the presentations. Or maybe we can continue with, oh no, he's a, Leonardo, you're a presenter now. Can you hear us? Yep.
Yes, thank you for allowing me to present. I'm going to share my screen, just a second, please. You should be able to see my screen. Can you hear me well?
Yes, we can see your screen.
Okay. Great. And good afternoon, everyone. I am Leonardo Messi from UMPM, and welcome everyone to this workshop. Today I'm going to present the automating work planning service called HAVOPS as a solution to manage the complexity related to construction works planning, the spatial interaction environment to check if the work plan generated fulfill spatial requirements, and the validation at the experimental buildings located in clusters. Let's start with an overview of case studies gone over budget or delays across years. The first one is the Montreal Olympic Stadium that registered a cost increase higher than 2,000% due to several issues related to, for example, job site layout and constructability, construction management and progress monitoring, and even structural collapses. The final cost of this second scenario, that is Sydney Opera House, was higher than 1,300% compared to the initial one, with 10 years of delay. This was due to proximal design and constructability issues due to project complexity. Another example is the Scottish Parliament was cost increase of about 1,000% with 3 years of delay. This was due instead to approximate design and cost estimation, and also constructability issues. With reference to the construction projects reported in these statistics, one of the most frequent reasons of failure is related to bad construction management that is directly addressed by the system I'm going to present called AVOPS. But indirectly, AVOPS positively contributes also to design and constructability issues by bundling jobs logic and grouping products related to the same work location into deliverables. Focusing today on construction management topic, we can explain that related issues can be justified as mentioning the complexity of the construction site. In fact, a construction site can be described as a complex system where many elements interact with each other in a nonlinear way. Managing complex scenarios like this is a well-known problem in literature. In fact, in this domain, the CINEFIM framework suggests to follow the following steps that are probe, sense, and respond. Practically, this leads us to define a strategy that consists in using a process-based approach for generating work plans and checking spatial requirements not included in the work plan. This is possible by running spatial simulation in a so-called spatial interaction environment. So being the job logic model as a BPM, when progress data are available during construction works, a new work plan can be automatically generated and spatially validated. So the following system architecture has been developed. It includes 4 blocks, as you can see in this slide. The first one includes an interface to manage deliverable and link them to process models defined by means of a BPMN editor. This notation was chosen because it is general enough to enable the second block based on a stigmergic algorithm to replan without the need to redefine the sequence of activity each time. The third block enables the project manager to adopt high-level decisions, for example, by modifying constraints in the job logic processes. And finally, the fourth one is the spatial interaction environment developed within a gaming platform. It enables to check if generated work plan fulfills spatial requirements. Finally, the interface with the rest of the Encore portal is provided by a REST API, and the implementation of this system is based on the interface to BIM renovation projects. In fact, the BIM is provided by the Encore engine in the form of 2FC files related respectively to the existing and the new construction phases. On this basis, we can say that deliverables can be defined and linked to process models, activities can be instantiated, and finally, work plans can be generated and then checked in the spatial interaction environment. Practically, it consists in carrying out intersection tests between boxes representing working areas. For this purpose, the following inputs must be provided. First of all, the work plan, where activities are linked to resources and BIM elements by their goods, and the BIM model, where BIM elements have a position in the space to which workspaces, so to which working areas can be linked. In this way, in the gaming environment, it is possible to check interferences between workspaces occupied by different resources during the selected days. In this slide, we can see that no conflicts have been detected for the selected days between purple and yellow workspaces. And the strength of this system relies on the fact that the process is continuous. So when another work plan is generated, according to work progress data that comes from the field, the work plan can be checked spatially in this interface to solve then eventual spatial conflicts. So the system has been tested on GR premises, where the following renovation works reported also in this slide have been executed between March 7th and April 11th on this building. The works are the replacement of 2 windows and the installation of the opening arms on the north facades, the renovation of the north and south facades, and finally the installation of 4 shutters on the south facade. Let's start with the validation process. As a first step, the project manager generates the baseline before work begins, and at day 2, crew leaders records work progress. We can see from this picture that scaffolding installation is completed at day 2. Existing windows have been removed and work compartments were sized. Finally, insulation panels have been installed for 20%. The project manager inputs this percentage within HAVOPs. Then activities constraints have been set in addition to the constraints previously provided in the BPMs. For example, constraints have been added here to consider the procurement delays of new windows due to real transport strike. Finally, HAVOPs provides a new work plan represented by light blue bars in this slide, whereas the previous one is represented by gray bars. Here we can see that the installation of the windows has been postponed because of delivery delays due to transport strike. Before to apply this work plan on the field, as mentioned before, spatial requirement must be checked in the spatial interaction environment. As shown by the previous work plan, only a crew is working on the north facade where the green workspace is located, so no spatial conflicts have been detected during selected days. This process has been repeated for each one of the following work plans. So the next step is replanning at day 5. We can see from these pictures here that insulation panels and plaster layers on the north facade have been completed. Insulation panels on the south facade is in progress at 10%, and the shutter supports have been installed on the south facade. This percentage, as shown before, have been inputted within HAVOPs. Then activity constraints have been set in addition to the one included in the process model. And finally, HAVOPs provide a new work plan validated within the spatial interaction environment. And here, some activities have been postponed due to strike delays, as shown in the previous replanning. Next, replanning showed that some other works have been completed, or to be more precise, in progress. In fact, we can see that the finished layer on the north facade is at 80%, and the installation of the insulation panels on the south facade at 75%. So a new work plan has been generated again and validated within the SIE. At day 12, work hasn't progressed because activities stopped in this period due to bad weather conditions. So in the new work plan, uncompleted activities have been just postponed to new working days. Like in the previous work plans, also here the work plans has been validated within the SIE. And another the planning shows here insulation panels and the plaster layer completed, where work progress on the north facade hasn't progressed. So a new work plan has been generated for day 16, and at day 26, renovation work on the north and south facade are completed. Shutters on the south facade have been just installed but not connected yet to the automation system. New windows and the automation system on the north facade have been completed. So in the new work plan, partially validated in the SIE, we can see that the remaining activities related to shutters and dismantling of scaffolding have been just postponed after day 26. Finally, at day 30, all the activities have been completed. So we can see here that all the activities at the 100%. To conclude, we can say that according to the validation test executed in CASRAS, in relation to real works, we have demonstrated that HAVOPS enables a frequent work progress monitoring, continuous replanning according to data that comes from progress, costs related to resources can be controlled during work execution, and finally, the spatial requirements of working areas can be easily checked within the spatial interaction environment. So thank you very much for your attention, and I'm available for every question and clarification. Thank you.
Thank you very much, Leonardo.
Thank you.
We are continuing on the agenda with the presentation on the building monitor and diagnostics, which will be done via a recorded video, since unfortunately our colleague from Smart Gateways, Dulcidio, could not attend.
This work is a collaboration between Smart Gateways and SPA. Both companies work in the domain of the Internet of Things, where we explore elements around interoperability, be it at the hardware level, where we look at how we can bring a range of different sensor networks within the same platform, and also providing different alternatives to expose that data so that it can be integrated in current building management systems as well. So of course, this approach has a higher flexibility, allowing again the integration of sensors of different nature, and also scalability, allowing older closed systems to be expanded and integrate new functionality. The main aim of this service was to create an integrated solution to monitor the energy consumption and comfort parameters in order to verify that the achieved improvements through the renovation process don't degrade over time. A set of requirements was required for this platform. On one side, to be an open solution that would integrate heterogeneous sensor networks, provide a RESTful API to allow a seamless integration with the Encore platform, be a low-cost integrated software, hardware integrated platform with low technical installation requirements so that it could be installed by anyone without any specific training, and also to create an effective dashboard to monitor the sensor's data. The created solution is based on the Smart Gateways platform architecture. This is a multi-layered architecture that allows day-to-day devices to be used within the same control network. As an example, a sensor is connected to the platform through its own middleware, so it doesn't really care about what is the technology behind it, as long as there is an appropriate middleware for this sensor. Is turned into a virtual object, so its properties and data is stored as a software object. This allows it to be used within an agnostic control network that then can be fed that information to an actuator, in this particular case a boiler. This information is also available through a cloud interface, allowing the connection with third-party services, allowing again the control loops to be executed from third-party applications. One critical element for the solution is the element used to sense not only the energy consumption but also the environmental factors. So one of the supported elements is smart meters.
These are both electric and gas, so the current platform supports MBUS and PLC technologies. An alternative, we can use pulse detectors, so which are only available for electric meters. Smart plugs allow the control and monitoring of individual energy devices, like heaters, for example. Clamps, so these measure the current that's going through cables, so we can individualize which elements to monitor, and also elements to be put on the power panels that allows individual measurement of power consumption within an electrical installation. For environmental factors, we supply to this project a variety of sensors, one that is able to measure temperature, luminosity, and movement, so good to assess user behavior within certain spaces. Other allows us to measure temperature and relative humidity, and we can also monitor air quality like volatile organic compounds and CO2 and carbon monoxide as well. The installation of the platform is pretty straightforward. The platform itself, or the solution, contains a gateway and a range of sensors that can be paired with it. So for wireless sensors that are provided, the process of pairing is pretty simple. It's just pressing a set of buttons on each device and gateways, and things work. For heterogeneous networks with other protocols are in use, the gateway provides a discovery service that can look for a variety of sensors that are on the attached sensor networks. Of course, some protocols, especially older protocols, require user intervention to create a user matrix for addresses and for configuration of devices. The platform provides a back office that allows all of the configuration of these settings, especially all metadata that relates to the gateway location, to the sensor location, and to make it easy to integrate with the rest of the Encore platform. Also, all of the IFC IDs that can relate to the plant of the building as well. A back office is provided for the installation side and the maintenance of the platform. This allows again for installation and configuration of the deployed solution, allows also for real-time monitoring for sensor health, and especially for battery powered ones to be notified when these batteries need changing. Also allows the update of firmware whenever there is a bug fix or an edit service that needs to be added to the platform. So again, just a view onto the virtualized sensor stack. So again, each sensor has a list of properties that reflect not only the properties of the sensor but also the recent readings. So those shown in pink actually show that those values have been just recently updated. All the other ones sometimes are filled in once the sensor is initialized, and they are never broadcasted again. Others are broadcasted every so often. The back office all allows, if the device accepts commands as well, it will create a list of the commands that for that specific device, and they can be executed directly from the back office. Other options include filling in details for the metadata for the device, and also looking at the current sensor charts. So it shows an update, or it shows a recent collection of data from each of these sensors, just to make sure that things are operating according to plan. So to integrate within the Encore solution, an API has been developed that other services can use to query the different gateways, the different sensors, and extract all of the relevant data they need for that execution. So query parameters as IFC IDs and tags are part of what's on offer through this API, allowing again other services to quickly map between the blueprint of the building and the sensors that are within those spaces as well. It also allows to subscribe for gateway alerts, so the API can still also inform third-party applications through its API if something is going wrong with the sensors, if there is a power failure, or if there is a faulty sensor in location. So as a dashboard has also been created for the users or for the system users, the platform users, to explore all the data, to look especially when you're looking at degradation of values, to do a direct comparison with previous periods and do a comparison between how external factors have been affecting internal factors within the fabric of the building. Again, we're looking at temperature charts, humidity charts, and comparison with previous periods, which can be defined as required. Now we have an illustration of a motion map. So this allows the system to indicate what are the more frequently times of the day where those spaces are used. So this allows the creation of a usage profile that then can be used to optimize heating and lighting requirements. An app has also been designed just as a quick reference, indicating not only allowing to explore the graphs with the variation for different sensors, but also giving a user a quick feedback in terms of the comfort parameters using a simple semaphore type indication that from green to amber and red, indicating what what is the comfort level within a defined space that is being monitored. Thank you for your attention. Apologies for not being available to answer your questions, but if you have any question or any query that you want to send to me, please use the email provided. And thank you for your time once again.
I just realized that I was talking and I was muted. My apologies for that. For the last presentation with regards to the Encore project, I would like to invite Carlos Franco from the Junta de Extremadura in Valencia in order to present the pilot implementation. Carlos, the floor is yours.
Muchas gracias. Thank you very much, Nico.
My name is Carlos Franco, and I represent the General Direction of Architecture from the Ministry of Mobility, Transportation and Housing of the Board of Extremadura. I'm going to explain briefly what our role as a partner within the consortium of the Encore project is, which has basically been providing the necessary infrastructure for testing, validation, and evaluation of the different tools and technologies that have been incorporated to the Encore platform. And also, as administration, you can see the potential of the tool team, since the Extremadura board has approximately 14,000 social housing. For 3 to 4 years, we're going at a rate of about 400 or 500 restorations, and therefore, we believe that this type of tool has enormous potential to improve not only the number of restorations that can manage to do per year, but above all, the quality of the same when it comes to showing greater transparency and involving all the actors that are involved in the rehabilitation process, from the users to the technicians, passing of course the builders, as well as any other actor that could be likely to intervene in the rehabilitation process. And without further delay, we enter a little recount to the role of Extremadura board. As I said, what we have been doing, above all, we've been providing an infrastructure to be able to serve as a stage to validate all the technologies and develop the project. For this, we have drawn from the Center of Innovation and Quality of the building located in Cáceres. This research center arose as a result of a European project, and that was developed in 2007. So from then until now has been a systematic material technology research center, strategic issues or facilities that are aimed at improving the energy efficiency of the building, but more specifically, the residential building. Prior to 2007, we just had control of quality of the building in which it was located, so material resisting tests were not carried out, mainly which was based on the control that the administration made over the residential park. But since 2007 to nowadays, this innovation center has become above all a center for dissemination and research in energy efficiency, in building the project of these two houses that we see on the left of the slide. And the operation for the testing and analysis of different energy efficiency strategies is very simple. There are two houses that were designed according to the standards of social housing that existed in Extremadura at the beginning of the first decade of 2000. They were made in compliance with the regulations at that time, which was the technical code of the two houses, are exactly the same. They are designed with exactly the same parameters, built with the same building qualities, and are also oriented north-south, in such a way that the south facade is able to take advantage of solar radiation for all passive strategies. And we do it in the most efficient way possible, in the functioning, and the two are completely monitored in such a way that when it comes to testing a technology, a system of material with which you want to experiment and know how it works on real environment. We keep the pattern building unchanged, while in the experimental building we can make changes, implement a material to improve the facade, incorporate some system or install, modify if necessary, an entire tree or the entire envelope, and then through the comparison of results that it gives us, the monitoring of the behavior of the experimental plane with respect to standard plane. We know how that new technology on that new system works. During the last years, from 2007, all kinds of tests have been carried out in this part, and we have modified absolutely all the parameters of the building's envelope. And in the recent years, we have incorporated, above all, many tests related to installations and energy system renewables linked to the residents. Also, our monitoring system, we have a small meteorological station to carry out energy studies, more precisely, since it provides more appropriate climate information to the environment in which the house is built, to make an energy evaluation of all kinds. And we also have sensorized each of the rooms, so in each of the rooms of the two homes, we have temperature sensor for relative humidity of particles per million in the air. So the flow of energy through the different parameters of the envelope in covered facades. For floors, we also have a sensor system specific to dig for each of the installation that you have in the building. But you also have the possibility of including new sensor systems in case we want to introduce a new installation or we want to test a new installation. To summarize, we have carried out tests on improving the facades and next elements that are incorporated into the building to improve the energy efficiency of the building. Different tests about carpentry, solar protection systems, and other strategies linked to the adaptation to climate change of the building. As it is the case in these pictures of JD cover, digital facade, and within the Encore project, what we have developed or what we have done has been adapting such infrastructures because the Encore project was requiring that our sample housing incorporate multiple technologies at the same time. In this way, at the end of the last year, between November and December, the data acquisition system was tested, developed by the University of Zagreb. Therefore, researchers from the University of Zagreb came here and they tested the lifting. As it has been shown earlier, the presentation of the universities, to see if they did the lifting of both the pattern building and the experimental building, since it was going to be the prototype that was going to be the building on which all the works would be carried out, and all other technologies would be treated for the evaluation of the other technologies that are incorporated into the Encore platform. A series of surveys were carried for the Extremadura board of the different partners to see which rehabilitation works could be in some way better to bring together or better resolve the testing of more technologies. So the better, therefore, the site design analysis of its decision system to pass the data that is closely related to the use of virtual reality glasses required to analyze. Well, we had to make some changes in the geometry or some substantial modification of the surrounds. As Leonardo previously commented, the AWOPS are closely related to the process of construction of the reform. Therefore, we need a series of actions that would be carried out in a period of time enough to carry out an evaluation, a study of this technology, and the CPMS that are related to the usefulness of the phases of use, since these houses are inhabited. We need an intervention that will allow us to simulate that they are inhabited, that is, introduce some type of automation within the rehabilitation process that we are going to propose. As a result of this survey, since the proposal to resize the windows, as explained Leonardo, on the north facade of the second plaza of the first floor of the north court, this would allow us, on the one hand, to analyze the AUDAX technology, and on the other hand, it would allow us to analyze and compare the energy analysis that have been carried out by Laurente from the University of Laguna. Since we are not only going to modify the size of the geometry of the whole, but it was also going to influence the energy behavior of the building, since we also introduced a new material replacing the initial aluminum carpentry with PVC carpentry. We also improved the scaling. The CPMS were going to be, as you have mentioned previously, evaluated through the introduction of home automation and automation systems. Therefore, these new carpentry shops that are going to be introduced, because we have also introduced systems with an arm and hydraulic arm with 5 positions, and 5 positions also automated systems that have allowed us to simulate natural ventilation. And we have also introduced shading system on the south facade, for all of which we have also automated to control the incident solar radiation that is introduced through the gaps. And as the most important measure when analyzing AWOPS, the improvement of the envelope is introduced. Both the south and north facade, that is to say, an action that involved a certain time. In this case, it was an ODAV work that lasted between 2 and 3 weeks, and that also allowed us to compare with respect to the energy analysis that could be simply analyzed from the University of Laguna and Laurente, a system of exterior technical element in the north and south facade. For the evaluation of ODAV that were carried out in the weeks prior to Christmas in December 2021, 2 researchers came from the University of Ancona, Alessandra and Massimo, and there was also staff from the board of Extremadura to evaluate the operation, evaluating the experience of users of augmented reality glasses, which were validated in, let's say, 2 steps. First, an IFC quote was entered that had been generated prior to the one the researchers arrived, and how was linked the building with the real model, and the users could see in the current state of the house, with respect to the IFC, a second state in which the IFC was modified with possible intervention or possible rehabilitation, in which the users allowed to modify established design criteria. or that possible intervention. All these opinions of the users were recorded not only through comments, but also were recorded in the augmented reality glasses tool itself. Also, the questionnaires were carried out in parallel. They were carried out every day for the entire duration of the evaluation. The action took place in December, and later we have a process of the time the administration slowed a little bit. So the work was not ready until March, until the moment that we can start the works that we had planned in the months before. So in March, when another investment was also moved to Cáceres, another researcher from the university embodied Leonardo in this case. And we have seen in the previous presentation during the testing process and water evaluation, we have continuous data collection without a site. That is to say, visits to work absolutely every day to see how the work was evolving from the moment one, since the installation of the scaffolding, the small ones, demolitions, the cleaning of the walls, and all this information was being contrasted with small or with meetings that we were doing both with the facultative management, which in this case was me, and with the leaders of the plants specialized in construction teams that were going to intervene in the different phases of the construction, as well as the manager who brought together and coordinated all these phases of the work. As we told Leonardo, the main problems we encountered were related to the schedule, especially with respect to the channel. So the timetable was altered because of the lack of materials. So first of all, there was a crisis with certain resources and construction materials across Europe, which affected us. The windows were scheduled to arrive almost at the beginning of the work, but they were delayed for several days. So this information has been put into the tool that Leonardo was developing. At the same time, we advanced with the work from indoors, including windows redimensioning in its different phases, and also the installation of the windows that arrived some days after the expected day. And they were installed using a mechanic arm, and later used in the CPS evaluation. Here we see a picture of the two automated windows. The last step included installing and automatizing sun blinds. So here we see the final work compared to the pattern building, which remained unchanged during the entire process. Later, after Easter, once the work finished, we proceeded with the evaluation of the CPMMs, for which Andrea and Massimiliano also came, and the objective of this tool was, in several rooms of the building, to maintain some comfort circumstances, so it continues to stimulate the presence, or that the assets were uninhabited for this. So we used a comparison between the temperature of the interior and the exterior by means of the automation system of the facilities. So we were heating and cooling the cabin as required, and when we surpassed the place of comfort that the researcher had acceptable at this time of the year, we opened the windows from the automation system to dissipate the heat losses. In the current phase, as was mentioned in the previous presentation today, since we were having problems, but from the board we couldn't give access to third parties, so our monitoring system, well, it was adapted to the project of this monitoring system that are going to control the evolution of the building, since the works that ended several weeks ago have been rehabilitated until the end of the project. So it will be evaluated and also measured, as it was mentioned before today, in terms of lighting, temperature, humidity, also relative data to the amount of carbon dioxide and particles per million. So thank you very much. Sorry for the previous mistake. And if you have any type of doubt, I will be delighted to answer it. I think we should take the opportunity to ask questions about the Encore project, because now we have finished all the modules related to the project. So if you have any questions, I think now it's the right time to ask them and not leave them for the end. You can raise your hand to ask a question. So my question is related to a speaker that it's not here. I'm not sure if someone could actually answer that. I think it's best if you ask this question to me later. Sure. Are there any other questions related to the project?
Thank you, Carlos. Lorena, shall we continue?
Creo que podemos aprovechar para hacer preguntas acerca del proyecto Encore, porque ahora ya hemos terminado lo que son los módulos del proyecto. Si alguien tiene alguna pregunta, creo que es el momento adecuado para no dejarla para el final. Podrían levantar la mano desde la sala, sí que van a hacer una pregunta nuestro próximo ponente. Si quieres, acércate y ponte por aquí, hacia este lado.
Vale, lo único que me pregunta es con el ponente que no está, no sé si alguien puede dar información. Si no me tengo.
Me la preguntas luego a mí entonces, porque creo que será mejor.
Vale.
¿Alguna pregunta más acerca del proyecto?
Well, let's move on to the presentation of the project. So, as we call them, those are local entities projects. And first of all, I'm going to share the presentation. So now that you can see it, great. So Diego Brooks is the manager of Sustainable Construction Cluster. He's going to present the IRIS project, and he will tell us a little about what he does.
El proyecto IRIS, que ya él nos comentará un poco de qué iría. Sí.
Hello everyone. First of all, I want to thank Lorena and the organization of the Encore project for inviting me. And well, the idea of my presentation is going to be to go through the IRIS project. And it's really interesting that the European R&D project feeds back and what it's doing as part of the transfer of knowledge and experience. And I think that it's an ideal forum for the kind of thing. So thank you again. So the IRIS project is a project of the Horizon 2020 framework program, and it follows the approach of co-creating cities and communities with a particular focus on intelligence and science. And well, in this framework we have 3 cities, let's say they are called Lighthouse, which are the city of Utrecht, the city of Gothenburg and Nice. And then 3 more cities that I call Salu, and before they were followers, because they were following the lighthouse, as we can say. So these friendly cities are Focșani in Romania, Alexandropolis in Greece, and Vasa in Finland, and the city of Santa Cruz de Tenerife here in Canary Islands in Spain. So the idea is that the cities, let's say smaller ones, what we learned through this is that the lighthouse cities, so they have big 5 major axes of development in these lighthouse cities. So we adopt in learning. So we go through session transfer, training of knowledge and more to try to transform through replication plans. Well, actually it would be more adaptation instead. So in our city, these learnings, here we have a mix of icons that represent each one of the actions within the big 5 scopes. So that's for another session to the transitional track. Now, if you wanted to explain in a point that goes from each of the track transition, but just broadly. So the first one is related to renewable energy, and the second one is flexible network. The third one, we're talking about mobility, and the fourth is about ICTs. So in the city, mainly in the smart city platform, and number 5 about creation, citizen participation. So within the city, there is a transversal axis in all the actions that the city must develop when it wants to transform or evolve. So counting citizens, with each of these track transitions, there is a series of specific axes as lines of concrete actions in which, well, different lighthouse cities are working on as follower cities. So in this case, Santa Cruz de Tenerife and the cluster as a partner of the project at the local level support Santa Cruz. They may identify areas of interest, for example, the city of Santa Cruz. We are not interested in centralized heating system, and we have ruled that out, but we are interested instead in intelligent networks, flexible networks, obviously the rehabilitation of public buildings for social housing. And enter like this, I'm going to do a mix of what is being done in the city in some of the areas that I think are more linked to the topic and the Encore project, where we can see things that taking place in this project. So for example, in the north, for instance in Gothenburg, they have a positive carbon footprint. Considering that the climate conditions in Gothenburg are not as favorable as here, it's really inspiring that a residential building has a positive carbon footprint of the energy consumption. So they have what they have there with the heating, so less, it's good. It's an inspiration for us here. So we win in Spain, for example, the building of a district, of a complete district of social housing, which is well in fact. We have seen one of the several blocks almost finished, but in some, they end up in which they are not carbon footprint positive, but they are almost carbon footprint. So these are socially, they are seeing many difficulties because they are people who have different origins, trajectories, and idiosyncrasies with different investments. So there has been done a very powerful social component. So also the technical component of the desired result, because if it does not exceed the partner party, then I can't fit the technical part, not in any interesting way. One interesting thing that is being done in Nice is the construction of a building, which was expected to be the tallest in the world, made of wood. But I think they have already planned one, almost twice as tall in Canada. I'm not sure though. So at European level, with this construction, it is enough high and it is made of wood. So it's not like an experience, of course. The carbon footprint of life in the building is much lower than the one of the traditional construction. And one more thing, for instance, the buildings in Gothenburg, they work a lot with photovoltaics in a place where half of the year there is no sun at all. So I return to stress the importance of those examples of Nordic countries with such adverse weather conditions. And from the point of view of renewables, for example, in this case, so what we can say, how can't we take advantage of this, since we are getting ahead of ourselves on this topic, and finally taking notes on this topic in the sense that, well, we have to take advantage of the 4,000 hours of sun that we have on Canary Island, and probably the amortization of the equipment, so the investment would pay off much earlier with respect to the Nordic countries, and Sweden in this case. An example of energy storage through geotechniques, for example, there are solutions, very interesting ones, than simple. So it's interesting to explain how the city of Nice had an impressive control center in which live a myriad of parameters of the cities, from the traffic to the climate and the pollution also. So the performance of building both public and some private companies that participate in the project, and it's very interesting because here they work well with modeling, in which, well, all the information is transferred to the city. to learn a little bit about the behavior of those buildings, which allows later to get some feedback on how they can be built better, and at the time of the design and so on. So already working with interesting technology. It's also very interesting how in the city of Gothenburg the competition is fostered. As we say here in the Canary Islands, they make the owners race to see who gets the best application, and they compare a series of characteristics of the buildings to allow these comparisons in terms of saving the distance between buildings. Also different characteristics of the buildings, and how they compete in the public image, of which ones are behind or and not achieving better results in energy savings and efficiency carried out and reducing carbon footprint. The public image of these companies improve based on this competition, and it's a kind of game that is voluntary, and it also allows the owners to build a corporate image that is very interesting, and in some cases they participate and they use modeling as well. Well, the case of a specific case of rehabilitation that only, if I remember correctly, in Utrecht, as the building typology was with no balcony or closed balconies, almost all the old double vinyl glazing is nothing compared to the triple with thermal brick and high efficiency, and so on, so that are being implemented now. Well, we can see a little bit some data from the modeling on how are representing the work in that building. So to sum up, because I don't want to go too much into detail, so there are different projects in Santa Cruz de Tenerife, and this with little representation of the different ones and the performance within a transitional track where Santa Cruz de Tenerife has bets to implement its replication. And I'm going to provide an example in which we are working slowly but regularly, also in collaboration with the University of Laguna, where we prepared so that all the modeling part of the building within this block, so it can be carried out in collaboration. And this block is the block of urban. So let's go on. This block has the characteristic of which there are several public buildings of different administrations, the municipality of Santa Cruz de Tenerife, the fire consortium, the channel of health, and also social services and a public school. And the idea of this project is to make a zero carbon block, or even a positive energy carbon, with the installation of photovoltaics on all facades, on all the roofs that I know that are available, with an integrated communication system for conduction of energy between the different buildings, so that the peaks of consumption and production can be affected and equated, to try to reduce external demand for fossil energy, if possible. And then in addition to that, as it's intended to establish and take advantage of water battery, it has just been incorporated into lines 910 and the future 900, and of the urban lines intended to be from 13 to 14, 15 and 5 and 21, that within the next 4 or 5 years of operation will begin to be replaced. In that matter, does not have a performance in a bus, but it can have a performance in a building. Then, so we want to take advantage of those batteries that are waste and turn them into resources for those buildings, so that we can definitely offset consumption in a direct way, and not only the carbon balance that renewables can allow, but also it's really self-sufficient block. So of course we also talk about rehabilitation of buildings, but that will be a phase later of after several years, because it's a very ambitious project. And of course everything is also controlled with building energy management system, not just one but several buildings, to see if the system equation, how different investments of each one of the actors are made in a project. And I find it very interesting, although you still have management of the fire station of the health center in Tomicano in Santa Cruz de Tenerife. To wrap up and shortly go over the topic of mobility issues, I think that one of the most relevant challenges the city of Santa Cruz de Tenerife is facing within the framework of the project. And since it already obtained financing for low emission zones in the old town, that will be expanded in the future with its restrictions of access and also a network of cycle lines, at which some areas of the road are shared with vehicles, speed restrictions and security control of vehicle speed. Also with control surveillance system for compliance with the safety terms, so that the cyclists can always be safe without taking up space from pedestrians, of course. So I'm talking about reserved lanes just for cyclists, intended as safe transport element. So this is an interesting and complex project that has many other interesting things, but I just wanted to share this little experience since we are working together on this project, collaborating, and I want to thank the university again. So that's it. Of course, I'm available for any questions, and thank you. Long way to get ahead of it, but we are working on it. Next, we have Maria Delgado from the Technological Institute of Renewable Energies from Tenerife. Good afternoon. Well, Maria, if you want to introduce yourself and tell us a little bit about the institute. Well, good afternoon. I'm Maria Delgado and I'm the coordinator of the Department of Sustainable Architecture. I'm also part of the technical team of the project that we're going to present you, which is the most important project developed within the program MACLAB 2014-2020. So this project, well, as the acronym says, we see most of the keys to improving capability in R&D and I structures in the sector of renewable energy and energy efficiency in the Canary Islands and Senegal. And the main objective of this project that we are going to present to you quickly is to promote excellence and applicability of scientific and technological activity in the renewable energy and also energy efficiency, contributing to sustainable development. And when this project was presented, we recognized something that we had already in mind at the Institute a long time ago, because, well, with no doubt, the way of developing new projects as interesting as Encore, or as the one Diego from the cluster just told us about, which I would like to congratulate, because I think that a little development of this type of project is the way that we have in Santa Cruz in principle, and after the rest of the capitals of the city of the island become leading cities, and they don't remain always followers, as he commented. But well, this is the way to develop this type of project, is to achieve that we make cities become leader cities. So we think that because it's very important that the technological infrastructure is in accordance with the project that we want to develop. So sometimes we have many project ideas, but we lack the technological capacity behind. So it is a little bit what we wanted to promote, both in the case of the Canary Island and in Senegal. And going to the partners of the project, from the Canary Island side, we have ITER, as well as the Insular Energy Agency of Tenerife, while from the side of Senegal, we have AEME and CERER, two entities linked to the Senegalese government and dedicated to the study of the economy and energy and renewable energies. The specific objectives of these projects are to improve research activities in scientific and technological infrastructures, strengthen the capacity of technical and teaching research staff, and strengthen the capacity of public authorities and fostering the approach of scientific activity to the public. So these are very ambitious goals indeed, but well, we hope that in the development of the project, because it's still a project that is just at the beginning of its journey, because we had some problems since it started during the pandemic, and well, everyone and everything has some difficulties since then, and we hope to be able to achieve within the main activities that were proposed at the beginning. So strengthening and optimizing the scientific and technological laboratories and infrastructures. Within this, so what has been done is the optimization of the existing lab, which is the research laboratory in photovoltaic cells that already exist in the ITER. And well, it's raised because it's optimization with new instrumentation, with new training for associated researchers. And on the other hand, the creation of the lab is a mobile laboratory of energy efficiency, and I'm going to talk to you about everything in this mini presentation concerning my knowledge, which is the part associated with energy efficiency in building, because we saw it's interesting the creation of a mobile energy efficiency, and it has already been discussed during this meeting. Well, it's fundamental in the reduction of emissions in the building sector, and this has to be linked for sure with the rehabilitation of the existing building cores in the new work that is already being done with the new technical code, with all versions that have been leaving the later. Included supposes improvements, but in our existing building compared to new construction, since it's quite expensive, let's say that both here and across Europe, with no exception, and with no doubt, working on it is a fundamental part of achieving the savings of energy linked to the use of buildings. And on the other hand, in order to promote these renovations and to be efficient and to really achieve the objectives, it's essential to have knowledge of the building that we are evaluating. We are no longer talking about prototypes such as those developed by the Encore project. But good, because we are talking about buildings that are already built and that do not have sensors, because the facilities are... What are the possibilities? They are what they are. And as Diego commented earlier in his example, for what it was like to work on the issue of housing, even though they are public buildings that are already in use, it always has the added complication. Also in this laboratory, not only allows us to have knowledge of the real operation, but by having that, as we have in prototypes and pilots, by having temporary data, it also allows us to make evaluation of the resilience of the building in the face of unforeseen events of future changes. The main values that we need to measure, since they are the physical parameters, the chemical parameters, the state of the envelope, which is fundamental, obviously, we can apply any type of certification program. We can enter the given data and items and buildings, because they have projects that have not undergone undocumented reforms. But obviously, it gives us a measure, but doesn't give the reality of the state of return. So we know well that between the plans and the constructions, there is an inevitability, there is the human part. With these jumps, we can determine the degree of comfort offered by the building and the ways to reach minimum consumption with maximum interior comfort. Also linking it to the actual use of the wing and forecast of the parameters. So actual use a little, because our experience is that we have realized that, of course, unplanned things, the building plans, the type of protection is a function of it, and then the way the user decides to use it, or the way the use is finally made, derives in a certain way as a function of it, because changes a lot the interior comfort of the building in the way a little. So what we do is that those already built buildings become temporary living laboratories, and we also make aware of the operation of their own, so of their own building. And another of the activities, the main project, was the diagnosis. Let's say that we already had the structures strengthened and optimized, or in our case, our mobile laboratory, well, created with minimal equipment. Obviously, we hope to have options to improve, and well, in the part of putting the diagnosis and start new lines of R&D, so within this, the first that we have, well, we keep working on it, but we already have certain monitoring data because it's the efficiency and the effectiveness of natural ventilation in educational centers to avoid contagion of COVID-2019. And this has been carried out within the framework of the Monitoring Excellence Network formed by many entities that are dedicated to building monitoring issues. And the objective of this study is to analyze the quality of the environment in educational centers of different characteristics through indicators of temperature, humidity, CO2, and the results allow us to analyze patterns of behavior during the exceptional period of the pandemic, and also now, with the new normality, as it is called, or the new conditions, giving us some information about the rehabilitation requirements of educational buildings and their potential to improve the residents' energy efficiency and indoor environmental quality. This is a project that was proposed at the Torroja Institute, and we found it very interesting because, they were really giving some ventilation instructions because they were equal for everything. So for the entire map at national level, and schools, because to greatest extent they were applying, because the windows were always open, they were wearing masks, and in many schools, apart from internal discomfort, not all places are the same, so there were places with a lot of indoor wind. There are places where the temperature is not as optimal as ours. And it was generating a lot of discomfort and increasing consumption. So what is proposed here is it's going to be a study for Spain's different points and evaluation of how things work. These are some pictures of schools here and educational centers in which we have been. And you can see how good ventilation systems are because they are very different across schools. And the punctual result of this work is that how consistent and how good measures are taken for minimum week and continuous in 2 classrooms per school. So we choose 2 classrooms first, and based on their location and type of activity that is carried out, and after some specific tests of ventilation times, the specific result was the analysis, what has been reflected in this graph, because the rise in CO2 peaks produce the increase in temperature, and this goes away, linking it with different activities of the class. We see, for example, in the CO2, at the beginning of the activity, in this case, is the example that we have here because it's below 500 ppm, and then you see how it starts to increase. So to say again, because some curious things have been seen, like influences, for example, that the students are doing one type of activity or another. So for instance, when they are taking an exam, there is usually another type of ppm. It usually goes up a little. So it's been possible to study 2 classrooms of each school and then put it with the joint result once. So we have all contributed through the data of the school studied by the Torroja Institute for funding from CSIC, and in fact a little bit of that collection and analysis of the joint data with the goal of getting some recommendation, some more associated with concrete data as a whole. And you see that the classrooms, the average slightly higher than 900 ppm are the classrooms, because the center of Seville and the classrooms of the centers of Navarra are in different climate zones and obviously very different from ours. So the average, because in the zone of 3 it is 619 ppm, in zone 4 we see that there is another one. Then good, logically, at the end, the one with some patterns allowing to operate, because it's seen that in the climate zone there are 3, having the best data on both temperature and CO2, it is a very temperate climate and it facilitates these tasks. And in the case, the colleagues who analyzed the centers of Navarre told us, of course, that obviously they couldn't maintain the continuous ventilation because they went through periods of being very cold, and then the heating system couldn't cope with it. And regarding the CO2 rate generation, was measured at an average of 14 minutes from the increase from 700 ppm to 1000. So the intention was to provide some possible behavior patterns depending on the location, depending on the type of classroom, and with well-contrasted data, because, well, in many cases the teams have been registering all the sites, so offering them a little bit of that margin of maneuver that they had for ventilation is to say, well, you don't have to have the windows all day open, but you can make intervals so you can see when those peaks rise or how often they occur, and the time it takes to decrease even a little, and that operating system of the classroom. Another of the main activities within the project would be the actions of exchange and common training of the technical research staff and teachers that we are all working on. And the part that is suffering more at the moment due to affection of the pandemic, but well, we hope to be able to recover it. However, yes, we've been doing trainings and our meetings have been held, but well, obviously everything is online, which sometimes is not the best way to share technology. Additionally, the implementation of technological tools for training on the energy efficiency. We design educational workshops, visits to take measures, and informative talks within the framework of the lab, both in education line 2, which is the one I was telling you before, and that has been developed because we have complemented all this more technical data collection with a little, introduce the students and teachers to what we're doing, which is the utility of a CO2 measurer. How does it work? What relevance does the temperature and humidity have inside? And also workshops that we have called Through Walls. We also edited informative videos of the 2 laboratories, both from LAIF and CSIC lab. Well, the dynamization is being tried with different sessions so that the importance is seen of the collection of data and the application of technologies, because it is in the rehabilitation and operation of a building. And this is a picture of the workshop that we have been developing within the framework of the mini fairs, also in educational centers a little, so that the children can see the importance of the walls that surround them as well, and how buildings behave depending on the material that forms our envelope as well. So we introduced a little, knowing how different equipment is used, what is the operation of how does a thermal camera work, what's the temperature probe, because it gives us one measure or another, and a little with what we have tried to make it later able to be applied. So this also a little bit of reflection on their homes and classrooms above all. And well, that's it. Goodbye, and I hope it wasn't too fast, but well, I think that we were out of time, so thank you to the Encore project, particularly to Lorena, because they have counted on us, and thank you for letting us give this small vision of the MACLAB project. Thank you very much, Maria, for the research work, and also thank you for spreading the word. I think it's really important also to make our young people aware of construction and ways to improve and contribute to our environment. I see also that you do a lot of good work there. And well, now we're going to give the word to the European project BIM Proof, to Antonio Lopez Rios, who is here. Hello everyone, thank you very much, Lorena, and thank you to the University of Laguna, and thank you to the Encore project for the invitation and the opportunity to learn more about your project in detail, and also to be able to share with you the project of the club that we work. Also, congratulations for the project, because it seems very interesting that you are reaching and what you reach as a conclusion. And well, we are in the middle of the project, and we are just giving a vision, a broad vision, where we have to take it to a level. There are certain things that seem very interesting to me. And as Diego mentioned before, it's nice also and interesting that all the feedback we share, and I think there are things about the project that could be also interesting. I'm going to make a very quick presentation of our project, BIM Proof, so that to give you an idea, and if you believe that in a certain way we contributed, and it's a way to share knowledge, well, we are delighted to keep in touch. And also the BIM Proof project is part of the range of the Age 2020 projects, with the goal of creating a digital twin, and we are mainly focused on the construction process, and it consists of using the models as data from the static, judgment and dissemination of the dynamic data that comes from a capture in the cloud points, pictures and more, and also those of IoT sensor that is useful, that can give information in real time about what is happening in the work. The project has three main parts. The first part is data entry. The second part is the processing of internal data of the platform. And the third part is the information that is exported to the user. So in the first part of the platform, as I said before, the BIM models, on the other hand, the point clouds that come from drones and piloted robots when taking automatically, also with pictures and 360 degrees photo images and with thermal pictures. We also incorporated the version of temporality implementing days with which they come from programs with diagrams of great interest on works planning. So in the part of what is given to users, what the platform offers, there are several supports, both visualization on tablets, computers, virtual reality, augmented reality, and also those devices carried by construction workers themselves to send notification on. So the goal of the platform is to be able to merge the dynamic data on all point clouds with the BIM model. Then the similarity of the true physical reality and the virtual reality can be identified geometrically, and then by leaving that reality of the geometries, it can be identified first, the geometry that is constructed is corrected or not, with the goal of having beams at the end of the work. Second, we can also identify if the execution times correspond to the times of the interior plane previously drilled. And this also allows for part 5D to be done, consisting in a preview of the payments of the economic tariffs of the work. And apart that, also because all the pictures that the drones and robots allow to identify risk situations in the work, that it's also one of the objectives to identify where there are thermal loads or zones. So for instance, after welding, it gets really warm and there is risk of causing a fire. So most of the risk happens when there is no one there working, and most of the fires occur when people are not inside. So there is also service control system that allows to detect where the unsafe elements are on site. Lack of protection nets or lack of barriers. And then the objectives of the project are to improve in the planning of the work and reduce delays, reduce also work accidents, and improve the efficiency globally. So there are 3 pilot use cases that are protection of the game, security and planning, and we have 3 industrial partners. That is to say, kind of end customers that would use the platforms that we have to verify in testing the closing steps and the consortium. But before this, we have 3 pilot works, one located in Switzerland, which is run by the HRS company and is also the one where I belong to. A second one located in Madrid that is run by the VIAS company, and another one located in Norway run by the AF Group company. The consortium is formed by Spanish companies. There are both industrial and robotics companies. Also in Germany we have Fraunhofer and the University of Stuttgart that participate in the development part of virtual reality and programming. In Switzerland, HRS and the University of Zurich. In Germany we also have the DIM company for the normalization part. In Norway, the AF Group with Catenda for the part of developing of the BIM platform. Also Sintef, the coordinator of the project. And in Sweden, VTT for the part of augmented reality and computer vision. And this is it. Thank you very much for this opportunity. So with this last presentation, we can consider the workshop as done. And if you have any questions regarding those local projects that have been presented, well, local, but they are also international. So if you have questions about the Encore project, you can ask them now. You are also welcome to make any comments. And well, if there are no questions, I don't know if Vico or Stefan want to make any comments. And this would sign the end of the workshop.
No sé si quieren comentar algo y con esto pues finalizaríamos el workshop.
Thank you very much, Norena, and also to the rest of the wonderful participants and also presenters. On behalf of at least the Encore Consortium, we were honored to be here today and present our results and breakthroughs. Unfortunately, we weren't able to participate in person as we would like because of the overall known situation. But in any case, it was, I believe it was a very fruitful and productive meeting and workshop. And I would like to thank everybody for their participation and interest in our project.
Well, thank you very much again. So you have the website at your disposal where you can send us an email from. Also, feel free to contact us for any doubt or problem. We are at your disposal for questions from the project's website. Thank you again.